Greetings, minions. Sorry, I'm on a Dexter phase today. We're learning a little bit about accuracy and precision in measurements for our class 440 and 442. This is as it's presented in our textbook, Holt Physics. Here we go. So, accuracy and versus precision, the two are very different words, yet in common language, they tend to be mixed up and used interchangeably. That is not the case in physics. They have very specific meanings, and we expect you to be able to use them as they are intended. So you may first be asking yourself why. Why should I be concerned with these? Because errors in experiments must be minimized. We do not want to have erroneous experiments due to erroneous data. When we collect data for our experiments as part of the bigger picture, remember, the scientific method says we observed something that caused us to ask a question. We formulate a hypothesis and develop an objective test of that hypothesis. We collect data and draw conclusions. And in that final phase, we make a report so that somebody else can review it. Now, we collect data. Sounds simple enough. Two easy words. Collect data. A whole lot of stuff concerned with collecting data. The two primary issues are error, method error, and instrument error. We consider method error as being introduced by the person taking the measurement. They're doing it wrong, reading the instrument wrong, using the wrong instrument for the job, like I mentioned in class about using a tape measure to measure the width versus using a ruler. A ruler used to measure the width of a room would introduce error because it may slide a little bit, may not be placed exactly. The ends of the ruler may not be exactly lined up. You may curve a little bit instead of following a straight line. There's any number of method error possibilities when you're talking about using the wrong instrument. Now, the instrument itself can also cause error, so we call that, of course, instrument error. And this is produced whenever the instrument malfunctions or is improperly calibrated. In other words, it is not compared to a standard and measuring exactly as the standard would measure. A ruler you may consider to be calibrated for whatever units we use, centimeters or millimeters. That particular style of ruler that we use is good for a very small percentage error, even though it may expand or contract when it gets hot or cold. The difference that it makes will be very small, and in fact small enough compared to the actual reading that it will not make a percentage difference. So just be aware there are two types: error introduced by a person and error introduced by an instrument. And both of these can lead to problems with accuracy and precision. So what is accuracy? It is how close an individual measurement or series of measurements are from the accepted or actual value. And where do you get this actual value? You can go to your textbook, another known or established source. Be careful using the web because you don't always get good answers from the interwebs. You know. Okay, so accuracy. You make a measurement. How close is it to the actual or accepted value? That's accuracy. Precision is how close a series of measurements are to each other. If you take a series of measurements which are very close, that indicates high precision. You'll remember, if you were there for my presentation on precision and accuracy in class, with the cards. We were trying to get to the 7 of diamonds. The first set was neither accurate nor precise, as it was like a king, a jack, and a 5, all of different suits. So a king and a jack and 5 is none of those are near to a 7, so it's not accurate. None of those are actually close to each other, so they're not precise. The second example was 3 aces of spades. 3 aces of spades, all very, very close to each other. In fact, they are the same, so we would say it was very precise. However, aces are nowhere near 7s, so we would say that it was not accurate, even though it was precise. The third example was a 10 of diamonds, a 9 of diamonds, and a 2 of diamonds. And you may recall I said that even though it's probably a little more accurate just because it was diamonds, it was even more so because if you take the average of a 10 and a 9 and a 2, let's see, that adds to 21, and there are 3 measurements, so you divide by 3. Oh, look at that. 7, the average is 7. So we would say that even though they're not precise, 10, 9, and 2 are pretty spread out. The average is exactly 7. So we would say that even though it's not precise, it is accurate. And then, of course, the fourth example was to have 3 7 of diamonds. Now I am completely precise and I am completely accurate. That was an example of both accurate and precise. Also about precision, the more divisions, that's a word, isn't it? The more divisions on your measuring instrument, the more precise its readings. What does that mean? If you have very few lines on your measuring instrument, like on our rulers, the finest line is in millimeters. However, if you use a what do you call it, a yardstick, that is in inches. Usually the finest line on a yardstick is an eighth of an inch. Fractions. Let's stick to the meter sticks. We all get to millimeters, very, very precise. Notice there on that lower scale that there are two sets of scales. One on the left with a lot of divisions and one on the right with fewer divisions. We would say that there is a higher precision on the left scale versus the right, even though it may be reading the same exact number like in a thermometer. This scale much more precise than this scale. All right, there you go. That's accuracy versus precision, and I will see you in class.